In this video, I am going to explain about some gas laws. In my last video, I have already teach you about Boyle's law and Charles law. So in this video, I am going to explain about Gay-Lussac's law and Avogadro's law. So what is Gay-Lussac's law? All these laws explain about the substances present in the gaseous state. The behavior of the substances present in the gaseous state. All these laws explain about gaseous state, right? So the Gay-Lussac's law states that pressure exerted by gas is directly proportional to the temperature when mass and volume is constant. Pressure exerted by gas is directly proportional to the temperature and mass and volume is constant. Here mass and volume is constant, right? In Boyle's law, pressure is inversely proportional to volume, right? Pressure is inversely proportional to volume in Boyle's law, right? But in Charles' law, volume is directly proportional to temperature. In Charles' law, volume is directly proportional to the temperature. So in this law, pressure is directly proportional to the temperature when mass and volume is constant. Mass and volume is constant, right? So this law is proposed by French scientist Gay-Lussac in the year of 1808. In the year this law is proposed. So the mathematical expression for this law is P is directly proportional to T, right? So pressure is directly proportional to the temperature. So we have to remove the proportional, right? So we have to add the proportionality constant here. P by T is equal to K, right? So K is proportionality constant. P is pressure exerted by the gas and the T is absolute temperature. K is constant, right? K is constant. So this law states that pressure is exerted by the gas is directly proportional to temperature. P proportional to the temperature. In Boyle's law, P is inversely proportional to the volume. Charles' law, volume is directly proportional to temperature. In Gay-Lussac's law, P is directly proportional to the temperature. So P1 by T1 is equal to P2 by T2, right? So whereas P1 is initial pressure, P2 is final pressure. T1 is absolute temperature, initial temperature, and T2 is final temperature, right? So P1 by T1, P2 by T2 is equal to K. That means P1 T2 is equal to P2 T1, right? Simply I am saying you have to remember this mathematical equation, then it is easy for you. So in Boyle's law, in Charles' law, in Gay-Lussac's law, right? So example for the Gay-Lussac's law. Is, so when we heat deodorant cans, right? Deodorant cans or spray paint cans. So in these deodorant gases, in these deodorant containers or spray paint containers, in this what filled inside? Gas is filled, right? In deodorants bottle we are using generally. So all these deodorant containers, gas is filled inside, right? So gas is filled inside, some gas is filled. So in this gas, what happened when we heat these spray bottles or spray paint containers? When we apply heat to this container or this spray bottles, what happened? So when we give the temperature to these bottles, so the gas present inside the containers are pressurized, right? When we give some temperature to these containers, the gas present inside the container is pressurized. So temperature is increases, so pressure of the gas is also increases, and explosion is happened here. Explosion is happened in this case. That's why the spray paint cans and some deodorants are labeled in that deodorant containers, right? So in that labels, what explains? In that labels explains that stored in a cool place, right? Stored in cool place. In that cases only explosion not happen. In very heat places, obviously the gas present inside the containers are pressurized and explosions are happen. Pressure is directly proportional to temperature. If the temperature rises, then obviously pressure of the gas is also rises and explosion is happen. That's why we have to store in a cool places. This is all about Lusac's law. The next gas law is Avogadro's law. So Avogadro's law states that the total number of atoms or molecules of a gas is directly proportional to the volume at constant temperature and pressure, right? If the pressure rises, then the change in volume happen. If the pressure is also affects the volume, if the temperature is also affects the volume, right? So here constant temperature and pressure, total number of atoms or molecules of gas is directly proportional to the volume. That means volume is rises, then definitely number of atoms and molecules of gas is also rises according to Avogadro's law. According to Avogadro's law, number of atoms or molecules of a gas is directly proportional to the volume at constant temperature and pressure, right? So here V is volume, directly proportional to number of moles, number of atoms or number of molecules, right? That's why I am expressing small n. Volume is directly proportional to the n. N means number of atoms or molecules. So here V by n is equal to K. We have to remove the proportionality. That's why I am writing proportionality constant K. V is volume of the gas, and n denotes amount of gaseous substances. N is proportionality constant. So V1 by N1 is equal to V2 by N2. Here initial volume, final volume. Initial amount of gaseous substances, final amount of gaseous substances, right? So this is Avogadro's law, right? So the volume rises, that means volume is increases, that means number of the gaseous substances is also increases. When volume decreases, then amount of gaseous substance also decreases, directly proportional. That's why V is increases, then obviously N is also increases. Number of molecules in 1 mole of gas. 1 mole of gas. Number of the molecule present in 1 mole of gas is 6.022 10 to the power of 23. The number of the molecules present in the 1 mole of gas is 6.022 10 to the power of 23. This is Avogadro's constant. Avogadro's constant. Right? So the number of molecules present in 1 mole of gas is this value. This value is called as Avogadro's constant. Right? So 1 mole of each gas at STP. It means standard temperature and pressure. Standard temperature and pressure. Right? 1 mole of gas. This 1 mole of gas at STP conditions, that means standard temperature and pressure conditions, have same volume. 1 mole of gas at STP conditions, that means pressure and temperature is constant, fixed values, standard values, will have same volume. So STP, standard temperature, is 273.15 kelvins. Standard temperature. And standard pressure is 1 bar. That means 10 to the power of 5 pascals. 10 to the power of 5 pascals. This is standard temperature and pressure. So 1 mole of gas at STP conditions will have same volume. But in generally, the number of moles and molecules of a gas is directly proportional to the volume. That means volume changes, then obviously amount of gaseous substance also changes. But at 1 mole of gas at STP conditions have same volume. At STP conditions only. So here you have to remember Avogadro's constant here. Number of molecules present in 1 mole of gas is Avogadro's constant. Number of molecules present in 1 mole of gas. 1 mole of gas is Avogadro's constant. Here all about Avogadro's constant.